एडमिट कर रहा हूँ मैं. We will start the class in 5 minutes. Wait, let's join some other people. Uh, Can you hear me properly? So please wait 2 5 minutes. Then we will start the discussion of question answer. This is first assignment. We will discuss 30 question on nature and property of material. This is introductory course. And I am Harishankar, a PMRF scholar at Roorkee, and under the supervision of Professor Kelato and Professor Ashish. So also course instructor is Professor Ashish. So we will discuss question like that. MCQ. These are 4 options. First question: which of the following has a first-line net structure? So if you want knowledge or if you know, please choose the right option. So this type of question we will discuss. Okay, let's wait 4 to 5 minutes. People are joining, I think, and find the answer of this question. Then we will discuss. Yes, please. 1 minute. So let this question, if you have idea or not. My voice is clear. If you have doubt or something, you can ask me in chat also, chat box. So let's discuss this question. Which of the following has a crystalline structure? So, do you know two type of non-crystalline and crystalline type structure are there? What is difference between these two? So let's see. Answer is, let we will discuss later answer first. See, this is amorphous and this is crystalline. You are seeing some patterning is there. Arrangement of atoms is in a particular way, but there is a random in amorphous. Okay, so this type regular arrangement in particular way in a particular fashion is known as crystalline. If atoms are distributed randomly, which is called amorphous. Okay, so answer is, which of the following has crystalline structure? Crystalline. Answer is A and B. Iron and quartz. You can see the quartz. There is a regular arrangement of atoms in a particular way. So, but this is glass. This is a random distribution, not a fixed arrangement or a array. So this is called non-crystalline. This is crystalline. Quartz or iron also has a abscissa structure as cubic centered, like atom are like, and all are similar. Atom are arranging in a cubic way, a centered cubic way. Okay, so iron and quartz are as crystalline in nature. Let's see, ask me like that, which is has non-crystalline nature. Non-crystalline structure. Now please answer the question. Yes, please. You can write in chat box also. Non-crystalline. One is glass. So both are silicon glass or window glass. This is non-crystalline. This is crystalline. Clear? So material it have or has uniform pattern in a particular direction in 3D direction. XYZ direction. Regular arrangement of atoms known as crystalline. If atoms are randomly distributed, known as non-crystalline. Okay. So let's move for next question. If you have a doubt, you can ask this question. Next question. Which of the following is a characteristic of non-crystalline structure? High density, low density, range of melting point, where varying structure. So from the previous question or diagram, you can select density will be high or low. Please choose one option from that. Low and high. Density should be low or high. Non-crystalline structure. Yes, please. Do you know density? Mass upon volume. How many mass is distributed over the volume is known as density. So density for non-crystalline should be low or high. You know, crystalline, non-crystalline. Crystalline has the perfect distribution. Let's say this type atom of arrangement. Let's say take me area or something. If atom are likely distributed for the volume. Some space is there. More space is used here in crystalline means there is no space or utilize of the space is more perfectly. So mass should be high in this case within the same volume. We get 1 meter cube volume in the both case, but mass in this case should will be high, and for crystalline is high as compared to non-crystalline. So density for crystalline will be high as compared to density non-crystalline. This is clear. If you have a doubt, please ask. Okay. So if volume is utilized perfectly, more atom can be occupied within the same volume as compared to non-crystalline because randomly distribution of the atoms. So volume may be left over in the case of non-crystalline. So clear this point to you. So non-crystalline has should be low density, and also if direction in particular direction atom are distributed 3D, 3D. So non-crystalline randomly distribution. So that's why varying in the melting point, boiling point, not fixed in the particular direction. Also, the structure is not fixed. Non-crystallization. Clear? Yes, please. If you have doubt, you can ask. So answer B, C, and D. Okay. This is 1D view, but if you go with 3D view, also like similar, you can see. So more volume will be used in this case. Utilization of volume is perfectly. If there is space, here you can see here, here, left of this only. That's why density is high in crystallization case, but in this case is low for non-crystallization, non-crystalline structure. Okay. One. So I think clear this question. Let's go for next question. Which of the following property of metal are superior those of ceramics? That question is, and for which of the following properties of ceramic are superior? So in NPTEL lecture, sir put the metal and ceramic properties. Please check and choose the correct option if you have an idea. Then we will discuss. First, choose the options. Yes, please. Which of the following properties metal are superior those of ceramics? Okay, good. Ductility. And other option. So, metallic is good, right option. Other also has toughness. Metal is also tough. And other question, which of the following is for ceramic? So you can see in the picture, are able to see metal has highness, percent, stuck high, okay, good ductility also high. So this is and also tough. That's why these two options are correct. Metal also we can make the hybrid like, but they are expensive and difficult to the same and join. But it depends on the combination of materials. Okay, if we mix the two metals or something else, this is called a hybrid. And these are the properties of metals. Range of strength depend on the composition of the processing thermal and electrical conductivity and active low corrosion resistance are having these properties of metals. Polymer also, please learn these properties. Remember, polymer also has light and low density and efficient and high strength per unit weight, uh, like stiffness, property high sensitivity temperature, elastome also, and ceramics. See, next question is on the ceramics. Which of the following properties of ceramics are superior? Hardness, ductility, toughness, air resistance as compared to metal, let's say, superior to those metals. Read the question. You choose the right option. If metal are ductile, this is correct. This is not correct. Which one is correct? You have two options now. From the above question, we can compare 3 and 4 question. So you can see hard in the property hardness. Okay. And also it is strength, good high temperature strength, good corrosion resistance, and brittle. Okay. So these are the correct options. Glasses also has a like properties. Learn these properties for exam point of view also. Next question, which the most positive element in the periodic table is? Yes, please. You know periodic table and most electropositive lithium, sodium, fluorine, and cesium. And other question is also, let me ask, is the electronegative also. Let's say 5A, most electro electronegative. Option are same. Lithium, sodium, chlorine, oxygen. I don't know. Highest electronegative is fluorine. But electropositive, which one is correct? Please see this strong electropositive in the periodic table. This side, like you can see the electronegativity and positivity. Strong electronegative is more tension. So in the lectures as discussed, and see electronegativity is represented by chi and value from 0.7 to 4. So lithium has 1, sodium has 0.9, calcium has 0.8. So you know the periodic table. This group, second group, third group, fourth group. So fluorine has highest electronegativity and cesium has highest electropositivity. Cesium can easily donate the valence electron as compared to other. That's why it's strong, highly or mostly electropositive. And fluorine can easily accept the electron while the formation the band bonding. Okay, please remember that also the periodic table in order, which is this from this side to this side is negative, and you increasing negativity, positivity. So see in this second picture, electropositive positivity is not tends to donate the electron, and electronegativity is tends to accept the electron, valence electron. Okay, chlorine, fluorine, bromine, iodine. So this is highest electronegative, while cesium is highest electropositive. So this is in the sizes. Fluorine atom size is too less. That's why nucleus tightly bound the outer cell electron also can accept from the other while the making bonding. And cesium easily donate can donate. So this periodic table like the order is going like that. Please remember. Let's say next question discussion. The energy of the secondary bonds. a kilojoule per mole is in the range of primary bond, secondary bond. So what should be the order? Yes, please choose the option. So answer will be A. You can see the order of the bond energy. Ionic bond is greater than 10 kg per mole. Covalent is 50 to 350 and metallic has 20 to 350 also, but secondary is less than 10 kg per mole. So A should be the right option. Also, diamond has high SNBI will be low, and in the case variable low, moderate and high. These are the elements. Okay, next question. Which of the following are belonging to the primary bond type? So you know in this question, secondary bond is energy like here at 10 less than 10 kg per mole. And this is belonging to primary or something else. So primary bond energy will be high. So which one name is covalent and ionic? In the ionic bond, you can see the energy greater than 100 kilojoule per mole. So that's why they are tightly bound, known as primary bond, also covalent bond, as the energy high. So these are in the category of primary. Okay. And secondary bond is the question will like that. These are two secondary and these and the is primary. So next question is also which of the following are belonging to the primary bonding type. So the question will be like that. Both are same. This is secondary. So this is already we discussed. Secondary bond and roles and hydrogen bond. They are weakly bonds. And the energy give more than 10 kb, 10 kilojoule per mole, bond will be break. So secondary bond type is between charge dipoles. So this bonding between charge dipole. So H2 bonding, hydrogen bonding like that, and water all also. The bonding type dominant in polymer material is polymer material we have seen in first slide. So which option will be correct? Anionic, covalent, metallic, water walls. If bond is tightly bound, they are known as harder and like iron and something which is bonding primary bond type. But in polymer, they are not like that harder than metals. So will lie in secondary bond type. So you know the secondary bonds, what are walls or covalent also. And when the polymeric rails bonding, when the walls, weak forces are between also covalent. Tenth question, which of the following is true for the polymer material? They have linear stress strain curve. They have very high molecular mass. They have a high strength to weight ratio, and they have low corrosion resistance. Which one is correct? Yes, please. Polymer. In previous question, you can see this is the picture. Question is, in at least understand they have very high molecular weight mass. So the long chain molecules CH2 like C C2H4 the power N means like 1000 more maybe. So molecular mass will be high, correct? And also high strength to weight ratio. The answer is the correct answer. Let's read next question. Which of the following can contribute to increase the bond energy of a ionic bond or ionic bond? Larger separation between the ion that then the equilibrium separation, larger difference in the electronegativity of the cation and anion. Increase the size of the anion, increase the size charge on the ions. Which of the following what about the increase the bond energy of the ionic bond? Ionic bond formed by my charge of the ion cation and anion donate the electron and accept the pi electron, then form the ionic bond. So if the atoms are more negative, like cation and anion, like cesium and fluorine, one energy will be high. this most time. And if the charge is increased on the ends, also responsible for high energy, high bond energy. So I need bond basically formed by donate of the electron and accept by the electron of the atoms. If the atoms anide and cation is strongly electronegative and electropositive, they form tightly bond between those. If we have a higher charge on the anion, also increase the bond energy. You can also see in this picture, two element has larger difference in electronegativity. They form the ionic bond like MgO, CF2, CCl, CO. These are the ionic electronegativity value. Like NaCl also has ionic bond. So next question also the bond energy. Which of the following is correct? In the increase the bond energy, what correct? Yes, please answer. So you know fluorine is highly electronegativity will be not. These are so in first and second compare between silicon and zircon. Which one is highest on the bond energy between Z and O and other is SiC. So this is positive, this is negative. So oxygen has higher electronegativity than carbon and also zinc. So that's why this is the order for ionic bond order energy. You can visit these books. There is a link for ionic bond type, ionic covalent, and other ones. Next question. Following attributes are necessary for a unit cell of a primitive lattice. Now come to the lattice, primitive lattice. Shape of the primitive lattice for units cell is not fixed. Primitive unit cell has longer volume than the non-primitive unit cell. Is the smallest repeatable units. It is the smallest repeatable units or it is more than one lattice points. So answer for primitive lattice. So shape not fixed, but this is the smallest possible repeatable units. Smallest repeatable unit cell known as unit cell, and primitive are not shape are not fixed. Okay. Next question, with the decreasing in the bond length, decreasing in the bond energy of the material will be decrease or increase, or doesn't change, or maybe increase or not increase. Okay, increase. So if bond length is decrease between the atom, let's say this means if this is the case decrease, then energy they are tightly bound. That's why closer come to closer. In this case, bond length is high, let's say, and bond is big, is strong, means higher energy. Bond energy is higher in this case, in this case is big, so increase. Okay, yeah, your option is correct. Next question. At the equilibrium separation between the atoms, the conditions specified are bond energy is minimum, potential energy is minimum, force is attractive, net force is zero. Let's say we have two type force, you know, one is attractive, one is repulsive. This type. So and force, this is attractive, and this is so be 1 minute. This is repulsive, attractive force below. There is a equilibrium point. So potential energy is minimum or here is potential energy dominating and going to down, and here is repulsive energy. So answer is potential energy is minimum at equilibrium and net force is zero. Repulsive and attractive force is equal. then net force will be 0. You can see in this picture also. This is the case. This is attractive force. This is the principal force between two atoms. Intermolecular forces and potential energy. You can see there is a mean of the potential energy. This force is equal, attractive and repulsive. This is the case. Next question, which of the following is R2 or a point lattice? Point lattice. It is a regular or periodic arrangement of the points in a space. Each point in the lattice is identical surrounding. Except the random distribution of the points in each space. Volume of the primitive lattice is larger than the non-primitive lattice. So, 4-point lattice, it's a regular and periodic arrangement of points in each space. Like, let's say, same arrangement in 3D. Each point lattice has identical surrounding. Let's say I'm choosing this point. A and P. So surrounding also should be similar, identical or similar. And periodic arrangement should be okay, which is known lattice point lattice. So you can see also in picture taken from the lecture, periodic and identical neighborhood. This is not a lattice because there is no surrounding, it's not identical. In this case, we can say this is surrounding neighbor is same, identical and periodic arrangement. There is not periodic arrangement also in this case. Next question. Pick out the correct statement in the following. Option A, primitive unit cell doesn't necessarily contain one formula in four molecule. B, a crystalline structure has lower bond energy than the amorphous structure. The choice of the set of unit cell in a point lattice is always unique. Higher coefficient of thermal expansion of material generally manifests to lower bond energy. Ceramics and polymers. Sorry. Composite material has the highest specific strength compared to metal, ceramic, and polymers. When we move down the group in the periodic table, the electronegativity of polymer increases. Thus, please choose the correct options. We have discussed the question on that. Please pick up the right options. Yes, please choose correct options. Yes, please answer. So answer is first. Primitive units doesn't necessarily have a contain one formula unit. Higher coefficient of thermal expansion material is generally equals to lower bonding energy, and composite material has the highest speed strength. Next question. Microstructure feature of the material that can be imaged in the scanning electron microscope is R. Yes, please. Microstructure feature of the material that can be imaged in a scanning electron microscope. So in a SAM, so on micro is SAM, we can see also grain and grain boundaries. Let's see. Next, right, we can see macro and we can in picture optically we can see optically or scan in this range, but highest range we can see by the 10 atomic level in the range of angstrom we can see in the 10. So in same we can see, let's say we have a like that feature in the our samples. So this is grain, let's say. This is grain and boundaries, the border is the boundaries. Okay, so this is also in nano or nano range, nanometer range. So in SAM we can also see by grain and grain boundary. If you want to see the distance between the atom arrangement, we have to perform TAM. So this is question based on the resolution. Next question, which of the following unit cell has the highest symmetry? Yes, please answer this question if you know. Cell systems. Monoclinic, hexagonal, triclinic, cubic. Highest symmetry. Yes, please answer in text. Also, you can write if you know. So answer is D. Cubic has the highest. You can see 720 crystal system, tetragonal, orthorhombic, hexagonal, is- or cubic, isometric, triclinic, monoclinic, rhomboidal, or trigonal. All three axes, sorry, in the cubic, let's focus. All three axes are equal in length and all are perpendicular to the owner. So this is give the highest symmetry. If we cut mirror image or like that. So next question, which one of the following unit cell has the lowest? Please choose the right option for this question. Lowest symmetry. Find the first not equal the things. If axes are not equal and all are not equals, then they give lowest symmetry. And perpendicular things also. Okay, writing. Yeah, this is unequal in the length and also non-perpendicular to another. This is lowest. This is highest cubic. Okay, next question. Higher coefficient of thermal expansion of a material is generally manifested of a strong bond, thermal vibration, weak bond, lower bond energy. With a higher coefficient of thermal expansion. Yes, please choose the right option. Think and choose the right options. Then we will discuss. Okay, D. Other. So let's see. Answer is also C is also lower bond energy, also the weak bond. We know bond energy is less, bond also the weak. And this is the alpha, which is thermal expansion of the coefficient is dependent. Most solid fluid will expand upon the heating and contract when they cool. The change in the length is with temperature for a solid material can be expressed as, and change in length directly proportional to the related to the bond length. If bond is weak, then thermal coefficient change in the length is will be higher of the temperature. So coefficient of alpha will be high. So this is you can relate it weak bond Also, if bond is weak, then bond energy also lower bond energy. Clear? Next question. If there are six electrons in the d orbital, you have d orbital, there are six electrons, but transition metals, the number of the unpaired electron in R. Yes, please solve this question. You can take 2 to 5 minutes for this question. Yes, please. You know how you can distribute the electron? S, P, D, F orbital. 1, 3, 5. 1, 3, 5, 7. Like that, the orbitals. Marriage. Apply the Bohm rules and fill the electrons. And find out the unpaired electrons. Okay. Other one, please answer. Let's say we have a 6 electron n equal to 6 and we have a d. First, distribute single electron and then paired if electron is left. So there are 6 we have filled. So choose the unpaired electron. You can see. Let me take another. 1, 2, 3, 4. Okay. So 4 is correct answer. Unpaired is not paired. Only singles. You are correct, Mohit. So next question, let's discuss which among the following bond is strong directional in nature. Metallic, covalent, ionic or van der Waals. Bond is strongly directional in the nature. Yes, please. Think about this question and choose the right option. If you have idea, then we will discuss. Okay. So the covalent is give the directional in nature. Why? The covalent bond are directional bond because of the atoms are bonded covalently and prefer a specific orientation in the space relative to one another. That's why solid having covalent bonding visit this site, there is more details about the bones. Let's discuss next question. Which of the following is not mechanical property of the material? Yes, please. This is simple question based on the properties of metals. Toughness, conductivity, ductility, hardness. Mechanical property. Think about this question also. Metal has all properties, but which one is not mechanical? Question asked like that. Okay. Okay. Other one, please answer. Only Mohit is giving the options. So B is conductivity. Mechanically, we can check the toughness by giving some force, ductility, and hardness. But conductivity, we have to go physical property. This is physical property. Conductivity, we have to check by electrically. Okay. So conductivity refer to the ability of material to conduct the heat. Thermal. This is thermal or electrical conductivity. This is physical property, not a mechanical one. So this is just by the force. Or mechanical property just by force, applied a force. Next question, which crystal structure is found in most metals? Metal, please. Metal generally in physical properties, also like that. That is referring to the like that conductivity inside the when we apply the energy, like giving the photons or like that, they give conductivity or fluorescence, luminescence are referred to the physical like things here. What happened inside the material with respect to the electronic level? Electron is excited or not, transferred or not from conduction band to valence band if semiconductor are there. Not semiconductor material, metals are like conduction and valence band are much inside, and free electron are there. How many electrons are there? That are referred to the physical properties. In the metal, semiconductor, or insulator case. Physical things like look like the border, but should be precise. Okay. Next question. Crystal structure is found in the most metals. Okay, thank you. But generally, which step should be taken by the metals? Tetragonal, cubic, hexagonal, or orthogonal? Metals are well set or harder and high density. So which one is give the high density in the arrangement? Highest symmetry also has. Okay. So answer is cubic. Most metal found in this cubic phase. Centered or either centered or either body centered. Cation sitting in the body or phase, and anion will be corner and corners. Metal bonds provide mobile equalized electrons, which is fundamental design to it. This is another explanation. Not this is the explanation for this. Which bound type is responsible for electrical conductivity in metal? Yeah, explanation is there. We see. This is the question. Which bound type is responsible for the electrical conductivity of metal? Ionic metal equivalent of hydrogen. For the electrical conductivity in the metals. Yes, please choose ionic or metallic or having equivalent of hydrogen. Let's read the explanation. Is there one question on batteries? So metallic bond provide mobile delocalized electron, which is the fundamental reason why metal conduct electricity. Explain it. Okay. Which crystal structure is found in metal? Generally, metals, this is fabrication, not based on the other things. In the nature, metals are found in the shape of cubic, most, not all, but most. And cubic, either body centered or face centered. Okay, they give highest symmetry. And what are the things we can expect? The property of metals, which is related to the structure. We can relate it to the property directly to the structures. Cubics, tetragonal or orthorhombic, and most metal are found in this cubic nature in cubic. Why found in cubic? The question is like that. Okay, you are asking. So check the property of metals. What is the property of metal? Ductility, most harder. So Which step is uh, give the hardness, cubic arrangement of the atoms in the space. Bond also responsible. One thing is the structure, another thing is the atoms bonding. So this is fundamental, like that simple question in nature, simply metal found in the cubic. And this is metallic bonds are responsible for electrical conductivity. Positive charged metal ions are surrounded by a sea of delocalized electrons. These free moving electrons can easily flow under the electric field. Metal has so many free electrons, which is known as C or delocalized electron. When we apply the electric field, these free electrons can easily move, and which is due to the metallic bond. The reason metallic bond give the free electrons in the metals. Next question, glass transition. Temperature is associated with crystalline solids, metals, amorphous polymers, or ionic compounds. Glass transition temperature is associated with. Yes, please answer. So let's see the option. Let's see amorphous polymers and see the glass transition temperature is characteristic property of amorphous materials. Glass transition only show the amorphous materials, okay, especially polymers, reacting to the one set of the large scale molecular motion without a distinct metallic point. Next, anisotropy in a material means what? One is isotropic, another is anisotropy. What is the cause? What is the meaning of that? Let's see the options. It has the same properties in all direction. It is transparent. It is direction dependent property. It is amorphous. Anisotropy. So, in the material, boiling point or something are dependent on the direction. So, an isotropic material means it's a direction dependent property due to the ordered uniform atoms arrangements, different direction, clear crystalline solids. Which of the bonding is the most common in ceramics? Bonding type of bonding in the ceramics most common. Yes, please. Answer is C. Ionic or covalent. Ceramics are typically compound of metal and non-metals elements with mixing bonding character. So that's why ionic with some covalent contribution. Last question of today's session. Which of the following is characteristics of the amorphous material? Amorphous material. Sharp melting point, long range atom model, isotropic behavior, crystalline structure. Yes, please. Amorphous characteristics. You know the amorphous materials. Let's say, let me discuss here. Atom are randomly distributed in the amorphous materials. This is crystalline. Well-ordered arrangement of the atoms is in the crystalline materials, while the amorphous is randomly distribution of the atoms. So which of the following is the characteristics of the amorphous material? Sharp melting point should be sharp or the varying. In the amorphous atom are randomly distributed. Check. Long range atomic order or isotropic behavior or crystalline structure. B. Long range means atom are, let's discuss, arrange, let's say, this is amorphous. Only you can see the atom are arranged. Let's say if we pick up this area, we found the arrangement in perfect way, but not over the material. So this is short range atomic arrangement in the amorphous. But in this line found you found throughout the material. This is known as long range atomic order, which is found in the crystalline material. This is short range. Okay, right, clear. If we found the order some in the specific area, but not all throughout the material, which is on a short range, which is found in the amorphous material. Clear. So this is the characteristics of the crystalline. This is not with answer. So answer is isotropic behavior. So melting point will be if the atoms arrange in a particular group. Thank you. Start nothing by crystalline in nature, long range. So the crystalline nature. So that is only isotropic behavior, which is more directionally dependent on the direction, and isotropic, which is dependent on the direction, which is only the crystalline. Clear? Read it out. Okay, so this is also the explanation here. Right? More postmodern more long range periodic atom arrangement on the short range that make are distributed in a randomly disordered fashion. There is no perfect equal direction in the internal structure because of the uniform randomness. Physical properties like reflectivity index and thermal efficient or conductivity are same in the all direction. They are known as isotropic. Okay, and this is the seven crystal system. Please remember the angle, also the bond relations A equal to B not C. So this is all about the lecture. Thank you for all of you for nice introduction. Tomorrow we will also discuss the same things. Get to your class. Maybe okay. Okay, we will discuss tomorrow also these things. Thank you.
Thank you, sir.
Okay, welcome.